All right, well, hello. It's really great to be here in person with all of you in Las Vegas. Thank you all for joining. My name's Mark Lohmeyer, and I lead the Compute and AI ML infrastructure product teams at Google Cloud. And while it's only been 8 months since our last Next, it feels like our product teams have delivered at least 2 years' worth of innovation since then. So I'm really looking forward to sharing all of that with you today. By the way, you may be wondering what's here under the white curtain, so that's a surprise for a little bit later, so hang tight for that. All right, now, at Google Cloud, we always start with our customers. So let's start with what we're hearing from all of you. You told us that you want to accelerate your company's overall transformation and capabilities. And at the heart of this are 3 categories of applications. First, everyone sees the transformational opportunity available with AI. And many of you are already integrating AI services into your applications. Second, you're looking to rapidly build new cloud-native applications. And third, traditional applications, which for many of you represent the vast majority of the workloads and are the foundation upon which your business runs. And as technology leaders, you have to enable all of this while your core responsibilities are becoming even more complex. And while IT has always been responsible for reliability, security, performance, cost, and sustainability, this is taking on a new and even more critical role in the era of AI-enabled services. For example, if you're taking an existing foundation model and you're fine-tuning it and grounding it with your own enterprise data, how can you do this securely to protect your corporate data assets? Or if you're doing inferencing of a large multimodal model, how can you ensure great performance and responsiveness, right? The difference in responsiveness of 10 seconds versus a few milliseconds is huge in terms of the customer experience. Or finally, how do you understand the cost to serve those models in an application and then drive that down so you can scale your customer base profitably? Having the right infrastructure really, really matters more than ever. And it's pretty clear to us that the old approaches are not going to meet the new challenges. We've never seen the types of demands that these AI workloads are placing on our infrastructure. This chart that you see here shows the growth in the size of the number of parameters in large language models. They're increasing in size by 10x per year over the last 5 years, 10 to the 5th. That's a lot of zeros. So it's pretty clear we can no longer just throw more general-purpose hardware at the problem because the benefits of Moore's law are starting to slow down. For example, transistor count is still doubling every 2 years, roughly, but no longer at fixed cost or fixed power. As a result, we need a more intentional approach to cloud infrastructure. So let's talk about how we're innovating at Google Cloud to lead the way in addressing these new customer requirements and challenges. Our strategy at Google Cloud is centered around the idea of delivering workload-optimized infrastructure. We look at the unique needs of each and every workload, and then we design and optimize at a systems level across hardware, software, and services to deliver against those outcomes that I talked about before and that our customers care deeply about. And within this, we're also using AI to dramatically simplify infrastructure operations for our cloud users. So let's now get into how this approach and this strategy is resulting in concrete benefits for each and every type of workload, starting with AI workloads. But before I go there, first, let me share some broader context on our approach to AI at Google Cloud. More and more customers are choosing Google as their strategic AI partner because of our unrivaled expertise across all the relevant domains. It starts with industry-defining research. In fact, the original Transformers paper, which is the foundation for all the large language models that are taking the world by storm today, came from Google research. We then channel that research into cutting-edge models such as Gemini and many more. But it's not just about our models. It's also about embracing the ecosystem and open frameworks, and Google is a great partner and great contributor here. However, the models by themselves are not enough. You also need to scale them safely in production applications. And we have unique experience running applications that serve literally billions of consumers around the world. And to do all of this, you need to build on the best infrastructure. So now, let's dig into our AI-optimized infrastructure. Google Cloud AI Hypercomputer is our end-to-end systems architecture for AI workloads. It's based on over a decade of experience designing and scaling some of the world's most advanced AI infrastructure and services. It starts with performance-optimized hardware across compute, storage, and networking, delivered as ultra-scale data center infrastructure, leveraging technologies such as high-density deployments, liquid cooling, optical switching, and more. Within this, cloud TPUs, GPUs, and CPU extensions provide the widest range of accelerated AI compute options. Next, through our open software layer, we enable extensive and optimized support for all the leading ML frameworks, including JAX and PyTorch, and the ability to scale AI workloads across physically disparate hardware deployments with multi-slice training and multi-host inference. With Google Kubernetes Engine, or GKE, integration for orchestration to help developers accelerate and maximize the utilization of that underlying hardware. Finally, we want to make it simple and easy and cost-effective to consume these services by offering highly flexible consumption models. In addition to traditional options, we also are introducing new models such as Dynamic Workload Scheduler, which is designed specifically for the unique needs of AI workloads. Ultimately, the purpose of the AI hypercomputer architecture is to improve system performance and efficiency, and this is something we apply internally within Google as well. Overall, we find that with this approach, we can run more than twice the effective efficiency relative to baseline hardware-only techniques. AI hypercomputer can also be flexibly deployed. Our open approach ensures that we are ready to engage at all layers of the stack. For example, earlier this year, we announced a broad partnership with Hugging Face to allow developers to use Google Cloud infrastructure to further open innovation in AI. This allows developers to train and serve thousands of Hugging Face models using Vertex AI and GKE. And as the AI landscape evolves, we'll continue to enable an ever-expanding array of ecosystem solutions, bringing all the benefits of AI hypercomputer to our partners and our customers in whatever way they want and need to leverage it. Based on the strength of our offerings and our strategy, Forrester recently recognized us as the clear leader in AI infrastructure solutions. And we scored a perfect 5 out of 5 on 17 of the 19 evaluation criteria you see here. Not too bad, but my boss is asking when we're going to finish off those last 2, so we'll see how that goes next year. Now, at the heart of the AI hypercomputer architecture is our industry-leading portfolio of accelerators, spanning GPUs and TPUs, covering the full spectrum of your AI workload needs. And we have some really exciting news in this area, so let's dive in here now. Let's start with an update on TPUs. TPU stands for Tensor Processing Unit, a highly specialized and optimized processor designed by Google that enables some of the fastest and most efficient machine learning systems in the world. We've been developing and delivering TPUs for over a decade now, and many of Alphabet's key products, including Search, YouTube, Gmail, as well as state-of-the-art Google AI models, such as Gemini, are powered by TPUs, serving billions of users around the world. All right, so now we get to see what's under the curtain here. So since we're in Vegas, voila. Here is the TPU V5P. So you get to see it up close in person. It has 2 times the flops of the previous generation and 3 times the high memory bandwidth. You can see the TPU chips there on the board. So, you know, these chips and these systems are pretty impressive. But where it gets really interesting is how we deploy these at massive scale in our data centers. But rather than just talking about that, I'd like to actually show you. So recently, some of our product managers shot a video inside a Google data center housing these systems. Let's watch it together now, and we'll see if we can hear them over all the noisy data center fans going. So with that, let's go to the video.
To show you how the AI hypercomputer comes to life in a data center, let's think about how we set up a training job for machine learning.
Now, this is where it all begins, with the performance-optimized infrastructure that is at the very core of AI hypercomputer. A scheduler or an orchestrator kicks off a training job that creates a compute cluster. For AI workloads, these instances use accelerators like Nvidia GPUs or Google Cloud TPUs. This is a compute engine rack filled with A3 VMs powered by Nvidia's H100 Tensor Core GPUs. Our custom-designed 200 gigabit per second intelligent processing units, or IPUs, create a separate data channel for GPUs to communicate with each other and bypass that CPU host.
A TPU is a tensor processing unit. Each chip has tensor cores with 4 matrix multiplication units, or MXUs, that do the actual arithmetic. TPUs are custom built in-house. They're specifically designed for artificial intelligence. It's all in there. On a single machine, TPUs can have 1, 4, or 8 chips, and multi-host workloads can use hundreds or even thousands of these chips together as a pod or a pod slice. Multi-slice training jobs can even use tens of thousands of chips. This is all amazing. Everything in here is at a scale that it's just hard to wrap my brain around.
And you know, when we moved to OCS for networking, we created the opportunity to reduce power consumption by up to 40%. This high-performance, energy-efficient, power-dense infrastructure offers a path to more sustainable IT. But Hira, I think it's time we need to get back to Las Vegas. We hope that you all enjoyed this look into what makes AI hypercomputer a reality. Back to you, Mark.
All right. All right. So thank you, Chelsea and Hira. Truly amazing stuff. So today, I'm really pleased to share that TPU v5p, our most powerful and scalable TPU to date, is now generally available, along with TPU v5e, our most efficient TPU to date, which is also GA. As you heard from Chelsea and Hira, TPU v5p can scale to tens of thousands of chips connected over a lightning-fast OCS network with an optimized software training stack, resulting ultimately in the ability to train large language models nearly 3 times faster than the prior generation. This means customers like Salesforce, Lightricks, Essential AI, and Google's own DeepMind research can train massive models in just weeks instead of months, iterating faster and realizing better time to value. Now, to enable choice and optionality for our customers, we're also delivering AI-optimized infrastructure based on Nvidia GPUs. We're pleased to announce that next month, customers will be able to access our latest Nvidia H100-based instance, A3 Mega. Compared to the prior generation, A3 Mega will feature twice the GPU to GPU networking bandwidth to accelerate training and inference workloads for some of the largest models in the world. In addition, we're bringing the next generation of Nvidia's newest Blackwell GPUs, including B200 and Grace Blackwell 200, with NVLink 72 to Google Cloud starting early next year. Deployed on Google's 4th generation of advanced warehouse-scale liquid cooling, the Blackwell generation GPUs will also feature the next generation of Nvidia networking. Google Cloud instances based on Blackwell GPUs will, of course, be delivered as high-performance, reliable, elastic cloud services with the full capabilities of our AI hypercomputer architecture to power the next generation of AI training and serving. Now, shifting to open software. Open source software is a key catalyst for much of the innovation happening today, and Google Cloud is a top contributor and innovator here. Last year, we open sourced MaxText to provide performant and customizable LLM training on JAX on TPUs. Now, we're expanding it to support Nvidia GPUs as well, delivering industry-leading LLM training performance with JAX across both TPUs and GPUs. Next, we're introducing Jetstream. This is an open-sourced, throughput and memory-optimized LLM inference engine for XLA devices, starting with TPUs, that offers up to 3 times higher performance per dollar on Gemma 7b and other open models by using advanced techniques like continuous batching, quantization, and efficient attention algorithms. We also continue to advance PyTorch XLA with new techniques delivering up to 3 times higher training performance for image diffusion models. All right, now on to storage. So, storage and data integration is fundamental to every stage of the AI lifecycle, as you see here. GPUs and TPUs are incredibly valuable and hungry resources and require high-performance storage to keep them well-fed and highly utilized. And this data needs to be highly resilient and secure. So we're significantly expanding our storage capabilities and portfolio to meet a broad range of AI use cases. First, we've optimized Parallel Store, which is an ultra-low latency parallel file system used for training models. We've improved the caching of training data from cloud storage to Parallel Store, delivering up to 3.9 times faster training and fine-tuning times, saving our customers both time and money. Next, File Store is also well-suited for models that require low latency, but with smaller file sizes. Because File Store is an NFS solution, all the data is immediately available to all of the GPU and TPU instances in a cluster, enabling thousands of instances access to the same data and delivering up to 56% faster training times. Last year, we also introduced Cloud Storage Fuse. This enables you to mount a cloud storage, Google Cloud Storage bucket as if it were a file system. Cloud Storage Fuse combines the high availability and low cost of GCS with a simple, standard file system interface. And now we've enhanced it even further with caching as well, keeping the data closer to the accelerators and improving training times by up to 2.3 relative to common alternatives. Finally, I'm excited to announce a new block storage offering tailor-made for AI called Hyperdisk ML. Suitable for inference and training across hundreds or even thousands of instances, Hyperdisk ML can serve up to 1.2 terabytes per second of aggregate throughput by automatically replicating and caching the data across the storage servers. Hyperdisk ML delivers up to 12 times faster model load times for inferencing than common alternatives. So huge capabilities across the storage portfolio. Now, networking also has a fundamental role to play in enabling large-scale AI and ML training and inference. First, to enable large-scale training, we're enabling petabytes per second of bandwidth between data center zones. Second, for inference, we're enabling load balancing algorithms which are aware of the TPU and GPU utilization and can automatically distribute traffic optimally across that set of instances to reduce cost. Next, within our compute clusters, our titanium-based network offloads enable high bandwidth, low latency data transfers across compute nodes in a cluster. And third, we're enabling large data pipes with cross-cloud interconnect and dedicated interconnect. So you can access and integrate data from any cloud across on-prem or other public clouds to Google Cloud for training or fine-tuning. For more detail on our cross-cloud networking and Google Distributed Cloud, which brings Google Cloud services to edge locations, my colleague Sachin Gupta had a great spotlight session earlier today. And if you weren't able to join that live, I'd highly recommend that you watch it when you get a chance on demand. All right. Last, as I mentioned earlier, we're also enabling new consumption models specifically for AI workloads. For use cases like small training jobs, fine-tuning, experimentation, and others, you want to be able to specify the amount of capacity and the type of capacity you need for how long you need it, and then be guaranteed it's going to be there when you need it, and that your job will run to completion. And of course, you only want to pay for it when you're actually using it. Makes sense. So, to support these types of use cases, we recently introduced Dynamic Workload Scheduler, or DWS. DWS supports two modes of operations. First, with calendar mode, you can specify the amount, type, and location of resources you need, and the specific calendar days that you need them, and we will reserve those resources for you. Second, with Flex Start mode, you also specify what you need, and we'll reserve the resources across our fleet and start the corresponding job as soon as possible. Customers like 2 Sigma are using DWS, as you can see from the quote here, very effectively to maximize their cost savings while still accelerating their AI workloads. All right, so we've covered the AI hypercomputer and the investments we're making here. But what really matters is how this comes to life for our customers. That's why I'm super excited to invite Salesforce to join us on stage here now to share how they have used these capabilities within their organization. So please join me in welcoming Sushma and Srinath from Salesforce. Hi, great to see you. Thank you. Hi, great to see you. Thanks for joining. All right, fantastic. So welcome, and thanks you both for joining. So Sushma, maybe we'll start with you. So could you please start by sharing a little bit more about what you both enable for Salesforce?
Thanks, Mark. It's great to be here with you and share our experience with all of you. We enable and provision infrastructure, trusted compute for AI research teams to support cutting-edge research, development, and deployment. We actively engage and collaborate with our internal and external stakeholder community, such as GCP, leveraging their expertise to propel us to new levels of scalability, efficiency, and innovation.
Fantastic. So thanks for sharing that. Now, maybe Srinath, over to you. So I know, maybe take us back a few years in time when you were starting before you had Google Cloud, and then how you started to take advantage of Google Cloud and our partnership to enable new capabilities in your environment.
Sure, Mark. We started with Google Cloud in 2018, and at that time, the AI research team was relatively small and predominantly relied on standalone compute instances for training their research models. And for storage, they used volumes that were not scalable and had lower throughput capabilities. And as the team and business expanded, challenges arose in managing standalone instances for individual research scientists. We knew this is not where our time was best spent, and we decided to move to GCP. And then the team turned to Google Kubernetes Engine as one of their first services on Google Cloud. With GKE, it allowed us for dynamic provisioning of instances, auto-scaling, and seamless integration with cloud monitoring. And research models are trained and hosted on GKE, where each researcher can schedule their workload on multiple flavors of compute engine instances. And data is stored in Google File Store instances, where each pod gets mounted with either a shared or individual file store. And all these resources are provisioned in a VPC network, which have multiple subnets with large CIDR ranges to accommodate enough compute resources.
All right, that sounds really great, and it's wonderful to hear about your journey with Google Cloud and the evolution of your infrastructure. So now maybe can you share a little bit more about the software and the frameworks that you enable for your researchers and your developers and the work you've done to help them be more productive?
Absolutely. So the researchers have a much better platform to work with now, and their flow goes like this. First, the ML scientist submits their YAML configuration to GKE with desired Docker image and resource configurations such as CPU, GPU, and memory. Then GKE provisions the compute nodes for the configuration in the YAML and pulls the container image from container registry onto the node and creates a pod. And once the desired workloads get completed, Kubernetes Engine Autoscaler reprovisions the compute engine nodes. And on the software frameworks, we use both PyTorch and JAX, which are both popular machine learning libraries with specific strengths. And we use JAX mainly on TPUs, and there was no need for customizations. We were able to use it right out of the box on Google Cloud. And for GPUs, we use PyTorch.
Yeah, that's great to hear. You know, that choice and flexibility is really important for a lot of our customers. That's why we're making the investments we talked about before around JAX and both PyTorch. So it's really great to hear how you're using that within your environment. So, you know, since that initial deployment, maybe you can share a little bit more about how this environment has evolved over the last few years.
Sure. Starting in 2019, we began utilizing Google Cloud Platform's TPUs to scale our models to billions of parameters in size. Since then, we have used TPU v2, v3, and v4. And as our data volumes continue to grow, we also saw an increase in throughput by utilizing file store high-scale instances.
Right, that's great, so thank you. So it's great to see how you're using, you know, virtually every aspect of the AI hypercomputer architecture, from GKE policy-based to GPUs and TPUs to JAX and PyTorch. Really fantastic to see how you've enabled that, you know, in your environment. And you know, Sushma, maybe back to you before we close here. So looking into the future a little bit, can you share more about what's next for your environment on Google Cloud?
Sure, Mark. We are thrilled to make such rapid progress in foundational research through AI hypercomputer. We are using the latest generation TPU v5. In fact, just last week, we got the results from our early testing. We are seeing the training time cut down almost in half for our foundational models, and we are still improving. We recently started using Google Dynamics Workload Scheduler to make it easy to access Google GPUs. We're really excited to continue our research using conversational AI, natural language processing, multimodality, and time series intelligence to solve problems for our enterprise customers. Running on Google has enabled us to accelerate product innovation. Thank you for the partnership.
Well, thank you both as well for the great partnership. Thank you for your investment in Google Cloud. And thank you most for taking the time to be with us today and share your journey with us. It's been really great, and we look forward to an even deeper partnership going forward. Thank you so much.
Thank you.
All right, so AI is clearly top of mind for all of us right now. But we also know that for many of you, the vast majority of your workload are the ones that you use to keep your business running are cloud-first applications and enterprise applications. So now we're going to shift gears to look at what's next for those workloads. From dev test to mission-critical applications and everything in between, we're delivering workload-optimized systems across compute, storage, and network for each and every workload. And we're really excited to announce the most significant expansion of products and capabilities across this portfolio, as you see here. We'll go now through each of these, starting with Titanium. Unlike competing approaches that only use offloads and accelerators on the host, Titanium uniquely combines smart accelerators on host with a tier of off-host scale-out servers. This approach allows us to scale performance beyond what's possible on a single host. And it enables our market-leading price performance for products like Hyperdisk. Today, we're pleased to introduce 3 new capabilities enabled by Titanium. First, the ability to perform non-disruptive or hitless maintenance, complementing our live migration capabilities. Second, security capabilities, such as protection against data theft due to exfiltration, and preventing access to user data and user encryption keys by operators. Third, it enables new, high-performance, bare metal compute instances, which I'll describe in more detail later. Now, onto our new compute instances. We're excited to introduce C4 and N4, the next generation general purpose VMs powered by 5th generation Intel Xeon processors. These are the first such VMs from any leading cloud hyperscaler. C4 provides a dedicated slice of hardware for each VM, offers larger shapes, and is engineered to provide consistently high performance and a highly controlled maintenance experience. As a result, C4 delivers 19% better price performance compared to other leading cloud providers, and also has up to 80% better CPU responsiveness for real-time workloads. C4 is ideal for your most mission-critical performance and latency-sensitive workloads. On the other hand, N4 perfectly balances cost and performance by leveraging Google's innovative dynamic resource management capability, which enables us to efficiently utilize those underlying compute infrastructure resources and pass those efficiency gains on to our customers in the form of lower prices. As a result, N4 delivers lower computing costs overall, while still offering 18% better price performance compared to our prior generation N2 instances. By leveraging C4 and N4 in combination across all your general purpose workloads, you can achieve the optimal level of performance for every workload while also reducing your overall TCO across the fleet. Customers like Palo Alto Networks are enthusiastically adopting C4 and N4 to make the most of these benefits. Now, while general purpose compute instances are versatile and cover a broad range of workloads, some applications have even more specialized requirements. Applications such as scale-out databases, logging, and other storage-dense applications require large capacities of local storage with very high IOPS. To meet these needs, we're excited to announce that our new Z3 storage-optimized instances are now GA. They support up to 36 terabytes of high-performance local SSD with 6 million read and 6 million write IOPS. Customers like Aerospike are using Z3 to offer their services with both very high performance and amazing cost effectiveness for storage-heavy workloads. Now, moving along, some of our customers and our ISV partners need tightly controlled process execution with direct access to the CPU, or some cases want to use their own hypervisor. This fundamentally requires bare metal hardware, but delivered as a cloud service. To meet this need, we're really pleased to announce C3 Metal instances. With bare metal instances, you get the entire resources of the compute server directly available for your workloads, making the server inherently single-tenant for optimal performance. Partners like Nutanix, Red Hat, Replit, and many others are excited to leverage C3 Metal instances to enable their services to their customers. Next, let's talk about possibly one of the most mission-critical workloads in the world, SAP HANA. To support the highest-end in-memory databases, such as SAP HANA deployments, we're now announcing our new X4 memory-optimized cloud-native bare metal instances. With configurations up to 32 terabytes of memory, X4 is our largest memory-optimized instance. And with an industry-leading 3.5 nines single instance SLA, X4 instances are ready for the most mission-critical SAP deployments. Now, SAP and Google Cloud are partners, but SAP is also a customer of Google Cloud Infrastructure. With their RISE offering, the SAP ECS team operates SAP HANA environments for many customers on Google Cloud. And testing by this team has been very, very positive as they prepare to use this X4 system for their SAP RISE offering for our mutual customers. Now, moving on. Google Cloud has a long history of designing custom processors for specific needs. In fact, since 2015, we've released 5 generations of TPUs, 2 generations of video coding units, and 3 generations of tensor processors for Pixel phones. Now, we're bringing that same level of engineering prowess and innovation to general-purpose data center computing. For many customers, this is where some of the most difficult and critical decisions are being made. You need to balance competing priorities, maximizing performance while enabling interoperability, while also lowering costs and meeting sustainability and efficiency goals. That's why today we're really excited to announce Google Axion processors, our first Google custom-designed ARM-based CPUs. And actually, someone let me borrow one from the keynote this morning, so I also have one to show here live in person. Pretty cool. We'll put that away for later. We're going to be building on Axion as the heart of upcoming general-purpose compute instances. And as you heard earlier today, Google Axion is a breakthrough in general-purpose computing. Axion instances deliver up to 30% better performance than the fastest general-purpose ARM-based instances available from other leading clouds. Axion instances also offer up to 50% better performance than comparable current generation x86-based instances and are 60% more energy efficient than comparable x86-based instances. Axion will be fully supported by Google services such as GKE, Dataproc, Cloud SQL, and others, and will also power many of our internal Google consumer services. Because Axion is based on the latest industry standard ARM core compute designs, you can quickly deploy ARM-compatible applications with support from the large and ever-growing ARM ISV ecosystem and be confident that it will work out of the box on Google Axion. And many of our customers are excited to take advantage of these new capabilities, as you see here. Now, continuing with the range of compute options, Google Cloud VMware Engine, or GCVE for short, is a very popular choice for customers who want to rapidly move their VMware workloads to Google Cloud. Hundreds of enterprises running on Google Cloud VMware Engine have achieved better elasticity, better uptime, and enjoy the benefits of cloud-native networking and proximity to all the Google Cloud services. Recently, Broadcom and Google announced that Google Cloud will be supporting the new VMware Cloud Foundation BYOL license portability option. This is huge. Customers who have the new VMware Cloud Foundation subscription on-prem can now save over 30% by avoiding the need to buy new licenses. You can just bring your existing VMware licenses and only pay Google for the underlying GCVE hardware instance. In addition, you'll continue to have the option to purchase a license-included GCVE service from Google. We're excited to be the only cloud to offer these savings and this flexibility to our customers. So, many great compute options, but we're not quite done yet. Let's also talk about storage again, but this time in the context of general-purpose workloads, starting with block storage. Last year, we shared how Titanium offloads enable Hyperdisk to deliver better storage performance than any other leading cloud. Today, I'm pleased to announce general availability of Hyperdisk advanced storage pools. Now, historically, block storage capacity was stored in silos, in volumes, for each individual VM, where it was often significantly underutilized. With our new storage capacity pools, customers can purchase a single shared pool of capacity across workloads. By using a single storage pool, combined with thin provisioning of the storage to the VM, and with dedupe and compression within that common shared storage pool, we can achieve dramatically higher storage utilization and over 50% cost savings for customers in typical scenarios. Google Cloud, again, is the only leading cloud that offers such storage capacity pools. Now let's talk about file storage. Last year, we introduced Google Cloud NetApp Volumes. This is a great option for customers that have standardized on NetApp on-prem and want to bring those workloads and that data to Google Cloud. Today, we're announcing 3 new capabilities here. First, policy-based file tiering that enables you to tier data to colder and less expensive storage based on file access times, while still providing great performance when it matters, ultimately delivering up to 60% cost savings. Second, you can now create massive petabyte volumes, and we're tripling the performance, the throughput performance, to 12 gigabytes per second. And third, we're introducing a new flex service level for less performance-sensitive applications, enabling flexible storage volumes from 1 gigabyte to 100 terabytes with up to 1 gigabyte per second throughput. All right, so as I said at the beginning, we have a lot of new products and a lot of new capabilities to share, and we've covered a lot of ground here today. Now, I suspect some of you in the audience may be thinking, hey, this is great, But how do I know what to use across all of this, and where do I even start? Over the last year, we've heard from many of you that you spend too much time learning and operating clouds. So that brings me to our newest offering, Gemini Cloud Assist. This is our new generative AI assistant for Google Cloud operators. We're thrilled to bring AI assistants to help you design, optimize, and operate Google Cloud. Let's welcome Jeff Welsch to the stage to give us a peek at it.
Thanks,
Hey,
Mark.
Jeff, welcome. Thanks for joining.
Thank you. Well, hello, everybody. Thanks for coming today and spending this time with us. I'm very excited to talk about Gemini Cloud Assist today because, to me, it feels like we're at the precipice of maybe a new era of computing, an era where we don't even yet know what the possibilities lie and await for us and can change our computing capabilities. So in order to help communicate this, I'd like to do some demonstrations. And so these are going to be live demos. In the interest of time, and so you don't see my typos, I'm going to copy and paste some commands over. But what I want to do is demonstrate how we can create some resources, maybe some simple resources, more complex resources, and then also highlight how we can operate and optimize your environment. And hopefully after this, you'll understand how we can really help you use and learn about Google Cloud, both for the new and power users alike. So let's go ahead and jump right into that. And let's say I want to create a virtual machine to run a web server, a simple virtual machine instance. I might start with a prompt such as, let's see, how do I create an inexpensive VM for running a web server? Now, when I've submitted this prompt to Gemini, it's trying to understand what it is I intended to do. Now, I've intentionally left this prompt a little bit vague, so it is going to actually ask me for clarification. So it has identified, of our virtual machine families, there are 2 that it would recommend for running an inexpensive web server. The E2 and, wow, that just announced N4 instance, which, of course, I'm going to select because I think Titanium is bringing some great benefits to my use case. So now that I've provided N4 as my follow-up, Gemini has the data that it needs in order to fulfill my request and help me understand how to create that instance. And so what Gemini has done is created a G-Cloud command that I could copy and execute in any terminal, or use our native Cloud Shell integration to execute directly in my Pantheon instance. And so by pasting this command line in, I can edit this, modify it, or just go ahead and hit go and have that instance be created. So while it's great that I can create an individual instance, it's rare that an application really runs on a single instance. Generally, you're going to run an application across multiple instances. And so I might want to create a load-balanced and auto-scaling infrastructure to support this application. I could do that with G-Cloud, but I'm also a proponent of infrastructure as code and a fan of Terraform. And so I'm going to ask Gemini for help to create a load balancer that will auto-scale across VMs using a managed instance group and have some firewall rules installed. So this process requires creating multiple resources. Through G-Cloud, this is about an 11-command example. But with Terraform, I'm able to create this environment with a simple piece of code that I can copy out. Now, this has created an instance template that defines the configuration of virtual machines when they're configured. It's created an instance group that allows me to manage these at scale, and all of the associated load balancer and networking artifacts required, such as external IP addresses, et cetera. So now I can execute this Terraform code in my development pipeline and have that environment created. So it's great that Gemini can create resources, but we can also help you manage your environments. Let me just refresh my page here and go to my instance. Sorry. Hello. Full screen's getting me here. Instance groups is what I'm looking for. So let's say I've deployed an environment, an application running in that load balancer example with auto scaling. I have an environment here where maybe I'm trying to prepare for an upcoming event where I expect that I'm going to have an increase in traffic. Maybe my application is going viral, or I'm releasing a new product such as the N4 and I'm expecting an increase in traffic. So first I can look at my instance group and I can validate my configuration that I'm requesting my instances to auto-scale at 60% CPU utilization. I might want to tune that, but before I do that, I really want to understand what is the actual performance of my instances. Gemini can help there as well. And more than just create resources, it can interact with my environment and in real time query my deployments and understand what it is the performance actually is. So in this example, again, there's 2 managed instance groups, and it has asked me to specify which one I would like. And I'm going to choose Wiki Frontend, which is the one we just highlighted. Now, in the back end, Gemini is actually querying my telemetry data and my APIs to understand and display for me the average CPU utilization of the instances in that instance group over, in this case, the last 2 weeks. And so from this, I can see my average CPU utilization is, say, around 30%. So I have some headroom here. I might want to optimize this deployment and say, allow my instances to support up to 70% of traffic, and then also maintain my costs by restricting the total VMs to 12. I can ask Gemini for support in this regard as well to say, help me set the target CPU utilization at 70% and the max VMs at 12. So again, Gemini now with this very specific command can tell me exactly how to perform that. Now, it has created a G-Cloud instance or a command to do so. I can copy this to the command shell and execute this just as I could create an instance. Now, in this example, Gemini is executing against my running environment. It's not telling me how to create anything new. It's actually modifying my environment. You can see the command succeeded. And if I refresh the page here, and I scroll over, you'll be able to see that the target utilization is now at 70%. So Mark, with 4 commands, we've been able to create an instance, create a more complex compound resource such as an auto-scaling load balancer, and investigate and tune our environment.
Wow, that's fantastic. Awesome, Jeff.
Thank you, thank you.
So, you showed us the entire life cycle with Gemini Cloud Assist. Must feel pretty good to be done with the demo now.
Oh, it's a load off my shoulders, that's for sure.
Yeah. So should we head down to the blackjack tables after this?
Yeah, let's do it.
Oh, wait, actually, I forgot. You're not quite done optimizing yet from what I saw in the demo there.
Yeah, you're right. But the good thing is today we announced Google Cloud Assist, Gemini Cloud Assist for mobile as well. So let's wrap this up and go hit the tables.
What a surprise. All right. That's awesome.
Thank you all.
Thanks, Jeff. That was great. All right, so thank you, Jeff, and thank you all for taking time to learn more about our workload-optimized infrastructure portfolio. Collectively, as an industry, we're at a very, very exciting time. I hope you found this session useful for you and for your business, and thank you all, and I hope you enjoy the rest of Next. Thank you.